Alright, here's the solutions to the first quiz from Math 95. The first question asks, where is this rational expression defined? Kind of a scary looking rational expression, especially the numerator up here is just a huge mess. Fortunately for you, when we're talking about where these rational expressions are defined, all that we're concerned with is making sure that the denominator here doesn't equal 0. So we can really ignore everything up top here. This really messy, ugly looking thing has no meaning to us. To figure out where it's defined, we just look at the denominator here. So maybe the best way to figure out where it's defined, let's figure out where it's not defined. It's not defined if the denominator here, 2x squared plus 11x minus 6 equals 0. Figuring out what x's make this true is pretty hard to do the way this is written right here. But if we get a little bit clever and factor this guy out, then we'll be able to more easily answer the question. So the way we factor these guys out, first let's look at this first term, this 2x squared. The only way to get to 2x squared is with the 2x and an x. Then let's look at this. We got this negative 6. Negative 6, that could either be 1 times 6 with one of these guys negative, or 2 times 3 with one of these guys negative. So really we have a lot of solutions, a lot of possible solutions. I guess here it's kind of a guess and check game. Let's see, we want it to be positive 11. So maybe that's a little bit of a clue. To get to positive 11, one of these things, when we multiply whatever we put here times what we got here, and then add that to whatever is here times what we got here, we need to get positive 11, which is kind of a big number. If you look at these, the only way we can get something that big, one of them is going to be negative, right? In order to get negative 6, one of these has to be negative. Negative 1, positive 6, negative 2, positive 3, negative 6, positive 1. So if we want to get something as big as positive 11, we should put the biggest number, this 6, right here, because then the 6 will get multiplied by 2x and get us 12x, so get us close to this 11x. And now we just need to be 1 less to get where we need to end up, which if you throw a minus 1 here, minus 1 times x gives you negative 1x. So there's lots of different ways to talk yourself into why this has to be the correct solution. You might have just tried all the different possibilities. Maybe I should throw some minus signs in there. Sure, why not? 1 times negative 6, negative 2 times 3. You could just keep trying stuff until you get it right, but here's a way where it wasn't quite as guess and check. We kind of talked ourselves into it. So we're not quite done yet, but we've kind of done the meat of the problem. We now have something times something equals 0. The only way two things multiplied together can equal 0 is if either the first one equals 0 or the second one equals 0. So we kind of have two possibilities. If we solve this guy, add 1 to both sides, you get 2x equals 1. So x equals 1/2. Solve this guy, you subtract 6 from both sides, and you get x equals negative 6. So it's not defined if x equals 1/2 or x equals negative 6. So our final answer would be it's defined if x does not equal one of those two bad solutions. Something like this. You didn't have to write your answer exactly like this, but if you express this idea, you're in good shape. So that's the first question. Moving on to the second question. Second question asks to simplify this rational expression. It'll turn out that simplifying this expression is pretty similar to what we did in part 1. We can't just look at this and cancel anything, but if we factor out the top and factor out the bottom, hopefully we'll get something in common that we can then cancel. The top here, there's sort of a trick to it. This is a perfect square and this is a perfect square. Right? 4x squared is the same as 2x squared, and 49 is the same as 7 squared. So we have a difference of squares. Maybe you remember from class we can say 4x squared minus 49 is this first guy, this 2x, minus 7, and then that's multiplied by this first guy plus 7. If you didn't remember this little difference of squares trick, you could think of 4x squared minus 49 as 4x squared plus 0x minus 49, and do it the way we did the problem up above. To get to 4x squared, it could either be 2x times 2x or x times 4x. If you play with all those possibilities and these guys, the only one you'll find that makes these work is this solution here. Alright, and what about the bottom here? 2x squared minus 5x minus 7. We want to factor this guy out. Let's see. And hopefully one of the terms will cancel with what we got up here. So let's see what we got. Again, we don't have a 1 as our leading coefficient. We got 2x squared here. So the only way you can get to 2x is 2x times x. And then we want to get negative 7. Let's see, negative 7 is kind of nice. It can only be 1 times negative 7 or negative 1 times 7. I'm not quite sure what order it goes in, but if you play with those possibilities there, the only one that will get you to get to this negative 5 is if we throw the negative 7 over here and the positive 1 here. The way I came up with that is I was like, alright, negative 5x is a little bit less than negative 7x, and I can get negative 7x by putting the negative 7 right here times this x. But that's too far negative. Negative 7x is too little. I need to get back to negative 5x, so I need to add 2x more to it, which is exactly what I get from 1 times 2x here. So if you want to FOIL this back out to double check your work, feel free. But this rational expression can be written like this, and the nice thing about this guy is we can cancel out those two terms and say that this rational expression equals 2x plus 7 divided by x plus 1. So just so we have it all written up, something in the box, I'll put it right there. And that's the end of the first quiz.